the commutative property now. Now, to commute means to travel. That's why you hear things like the commuting public or the commuter train, right? Now, here, we want to find out if addition is commutative or not, if subtraction, multiplication, or division is commutative or not. So let's see. We look at an example. Suppose we have, in addition, 2 plus 3 plus 4. Now let us make 3 travel to the left. It commutes to the left, plus we're going to have 2 commute to the middle and 4 remain where it is. We could also make them travel again, you know. Suppose 4 travels to the left, plus we could put 3, make 3 travel, make 2 travel to the middle and 3 travel to the end. Let's see. Now the thing is, if we get the same answer to each, then we can say that addition is commutative. If not, then we would have to say addition is not commutative. So let's see what happens. 2 plus 3 is 5. 5 plus 4 is 9. Is it equal to this? 3 plus 2 is 5. 5 plus 4 is 9. Okay, working so far. What about this? 4 plus 2 is 6. 6 plus 3, 9. Okay, good. So based on that, we could see that addition is commutative, right? You could generally make a statement that A plus B plus C is equal to B plus A plus C is also equal to C plus A plus B. So addition is commutative. You can make the numbers travel and change positions and you get the same answer regardless of where they travel to. Now, what about subtraction? Is subtraction commutative? Let's see. Let's use some other numbers. Suppose we have 20 minus 10 minus 3. Now, let's put the 10 in front. 10 minus 20 minus 3. And we could also make the 3 comes at the front. 3 minus 20 minus 10. Now 20 minus 10 is 10. 10 minus 3 is 7. Okay, good. Let us see what happens here. 10 minus 20 is negative 10. Negative 10 minus negative 3 is negative 13. You can see already that subtraction is not commutative. And even if we go to the last part here and say 3 minus 20 is negative 17. Negative 17 minus 10 is negative 27. 3 different answers. So we can say that subtraction is not commutative. So let me mark here. What about multiplication? Is multiplication commutative? Let's try. Suppose we have 3 times 2 times 5. Is it equal to, let the 2 go to the left, times let the 5 go from the right to the middle, and 3 goes to the right. 3. Also, we could say, what if 3 goes to the middle, 5 goes to the left, and 2 goes to the right? Are we going to get the same answer? If so, then we can say the multiplication is commutative. If not, then we'd have to say that it is not commutative. Let's see what happens. 3 multiplied by 2 is 6. 6 times 5 30. Okay, good. What happens here? 2 times 5 is 10. 10 times 3, 30. Oh, seems to be commutative so far. Let's see what happens here. 5 times 3 is 15. 15 times 2, 30. Okay. So multiplication is commutative. It does not matter which positions the numbers travel back and forth to. It doesn't matter which position the numbers commute back and forth to, because to commute means to travel. Now, division. Is division commutative? We want to find out. Suppose we take an example where we say 50 divided by 10 divided by 2. Is it equal to, say, 10 commutes to the left, divided by 50 goes to the middle, divided by 2 goes to the right? Is that equal to, when 2 travels to the left, divided by 50 goes to the middle, divided by 10 to the right? Alright, let's see. If we get the same answer each time, then division is commutative. If not, then division is not commutative. So let's see. 50 divided by 10 is equal to 5. 5 divided by 2 is 2.5. 2.5. Is it equal to this? Let's find out. 10 divided by 5. Well, 10 divided by 5 is 0.2 is 1/5. 1/5 divided by 2 is going to be the same as 1/5 times a half, which is 1/10. This is 1/10. And since I have fraction here, let's write this as a fraction. 2.5. Now, we work that out. What about, well, we can see here that it's not commutative, but what about if we work this one out? 2 divided by 50 is the same as 1 divided by 25. That divided by 10 is the same as 1 divided by 250. So this is 1 divided by 250. So therefore, what we can say here is that division is not commutative. So here, addition is commutative, or we can write generally here, putting it in a more general term, is that A plus B is equal to B plus A. Alright? That's addition. Subtraction is not commutative. A minus B is not equal to B minus A. Now, as for multiplication, multiplication is commutative. So A multiplied by B is equal to B multiplied by A. When I was doing it with the numbers, I used 3 numbers. But the same argument applies whichever number of numbers you use. So A times B is the same as B times A. Multiplication is commutative. And then here, when we divide, we saw that A divided by B is not necessarily equal to B divided by A. So therefore, addition and multiplication are commutative, while subtraction and division are not commutative.